let f of x equal the function x over x squared plus 1 to the 3 halves as long as x is greater than or equal to 0, and then the function will be 0 as long as x is less than 0. And you're told that this is a probability density function, and you're asked to find the median. So if you have a probability density function, the median can be found. Here's how. The median of a probability density function is a number such that half the area under the graph of f lies to the right of it. Another way to say it actually could be the other side of that. Half the area lies to the left. Okay. So it's a cutoff where you are 50-50 to the right and to the left. So how do you find it? Well, there's two sides, I guess. If you look at the picture here, this is actually the function. You don't have to know what the graph looks like. But there's some cutoff where you'll have 50% of the area on the one side and 50% of the area on the other side. Now, total area is 1 before probability density. For a probability density function, the total area is 1. So I have half to the left of it and half to the right of it. And so we're going to set it up as the integral from m out to infinity should be equal to a half. And we're going to solve that. Okay. The flip side would be the integral from negative infinity up to m of f of x should be a half. And you could do it with that too. Alright, great. So let's go with the one that we're going to use. And let's set up that integral. Our job is to find the value of m that makes this happen. Alright, great. Once again, we're faced with an improper integral. We have to recognize it. Why is it improper? Because we have this upper limit of infinity. What do you do for an improper integral? You introduce a variable that will approach the issue of that makes the integral improper. So we introduce a variable called t, and we let t go off to infinity. Now here's our issue. We have to integrate. How do we perform this integration? What technique did we use? The key is to recognize that the denominator inside, before you raise it to the power, is x squared, and what's in the numerator is x, pretty much the derivative of it. Not exactly, but pretty much. In that case, then we're going to use u substitution. Let u be the inside part of the denominator, x squared plus 1, then du is 2x dx. You need x dx, so we're going to divide by 2. That numerator, x dx, can be replaced by half of du. The denominator is u to the 3 halves. And we're going to integrate that instead. That's simpler. Don't worry about the equals to a half part. We're just trying to figure out how to integrate. And so we'll pull the half out, and we'll call that u to the negative 3 halves, so we can do the power rule in reverse. Add 1 to the exponent, divide by the same thing. If you're at negative 3 halves and you add 1, that's adding 2 halves. So you'll still be at negative 1 half. So that's your new exponent. You should divide by that same thing, and what's going to happen is these two guys are going to cancel out. And you'll still have a negative, though. And it's best for you to write it as a positive exponent, and if you can, use a root. So negative 1 over root u is the antiderivative. So when we go back in terms of x, we just find that the antiderivative is negative 1 over the root of x squared plus 1. We did the integral. Great. Well, now it's our job to plug in the limits. We put a t in and we put an m in. All right. We need to perform this limit to find out what this limit is in order to solve for m. Let's take a look at that on the next slide. So we have the original problem set up, and now the point where we're at right now, it's our job to figure out what m is that makes this happen. So we go find this limit. What happens as t gets big? T gets big, add 1, it's still big, square root, it's still big. -1 or a very large number, it's a very small number, goes to 0. That's not raised to the 0. What I'm saying is that goes to 0. Because this goes to 0, then you're just left with solving the equation of a positive 1 over the root of m squared plus 1 then should be equal to a half. If it's going to be the median, cross multiply, and 2 then should be equal to the root of m squared plus 1. Square both sides. M squared plus 1 should be 4. Subtract the 1. M squared should be 3. Take the square root. M should be the square root of 3. Technically, there's plus or minus square root, but in the setup of the problem, you don't need a negative answer because when x is less than 0, your function is 0. And so your median turns out to be positive root 3. Here's the graph of it. When you're at root 3, that's the cutoff point. Half the area is to the left of that, and half the area is to the right of that. It's a measurement of center, different than the average, different than the mean, but it still is a measurement that you can use to say what the center of a probability density function is.